Of November Leetcode daily challenge. I hope I maintain consistency across the whole month, and let's get started. Okay, today's question seems like an interesting one. Where will the ball fall? Okay, so normally I don't read the question. I just try to look at the diagram and then test cases, and I try to figure the question out. So let's try to do that. So I guess the question means we have a 2D grid, and then each cell has values 1 or -1. 1 means going right, and -1 means going left. And we leave balls, we throw balls on top of each and every column, and then we need to know which out of which column that ball will come out. And if a ball gets stuck between the wall, then we need to return -1. And the if we have a wedge like this, like if you have a V shape like this, then the ball would come and stuck, it will get stuck here, it won't be able to go any further. So that's the question. You can read the question more, and the constraints are pretty weak, so we are free to do anything we want as long as it's not exponential or factorial range time complexity. As the as the constraints are a little weak, maybe we can try just simulating what the problem wants us to do. We can start from this point, then maybe we can go down. We can do what they asked us to do. I think that should work. Let me say, I'll create a function called as @cell, which would have two parameters, x and y, the coordinates of the ball, where x is the row number and y would be the column number. So I'll quickly have the number of rows and number of columns. It helps a lot, instead of writing the whole length of grid thing, you can just use n comma m. And so when do we get stuck? When we go on to the left of 0th column or onto the right of m-1th column. So we can do that. So if y is less than 0 or y is greater than or equals to m, in that case we return -1. And when do we come out? We come out when we go below the n-1th row, right? So if x is equals to n-1, then we may return the column name. And apart from that, then let's enumerate the possibilities of left and right. So if grid of x comma y, if it is equals to 1, then we need to check if it forms this kind of deadly wedge. Like if here if you see here the value is 1, then it would form a wedge if the value adjacent to it has a value of -1, right? So I will quickly have a check for that. So if the column next to it is not exceeding our bounds, like if we are here, then there is no reason searching going out, because going to the right, because there isn't any cell onto the right. In that case, if it is less than m, case and if its value is in that case it would form a wedge. So in that case I would return a -1. Else I will propagate. So if I'm here and if I get a value of 1, then I would go to the right of the bottom column. Hope you understand. So in that case, I would go there and return whatever I'm getting from that. It's kind of recursion. So the row number would be x plus 1 and column number would be y plus 1, because we're going to the right. And similarly, the same for minus 1. Instead of y plus 1, we need to check for y minus 1. Yeah, I think we handle both the cases. I think there wouldn't be anything else here, so I'll just return, because we know that every cell is either 1 or minus 1, so yeah, can just return, because it would never reach this. And then we can so we got this function at cell function. What it does is, if given that I start from x comma y in this grid, if I throw a ball at x comma y, where would it land? Would it go onto the right, or would it go onto the left, or would it come out? Oh, I think we forgot the wall case. So if we hit a wall, hitting a wall is it is synonymous to saying that we went out of bounds of this grid. So we could add that condition as well. We could add that condition at the start. We could start here. I think we have this condition. Sorry. We already handled that condition. We already handled that wall condition. I'm sorry. So what is this function, add cell function? So add cell function is it'll tell us what would eventually happen to a ball thrown at the position x comma y. So we are initially throwing balls at these positions, like we are throwing them at 0 1 0 2 0 3 0 4 and 0 5, and then we need to return their consequences. So let's do just that. Now this is list comprehension. I love these in Python. Or I could have used any for loop as well. It's not a big deal. Yeah. I hope it works. Oh no, it's not working. So why am I getting -1 here? Why? Let me debug it. Let me print what's happening to x comma y. And instead of looking at the whole thing, I'll just look at the first one, because that's why we're getting the wrong answer. And I'll comment this out. Okay, so I'm at 0 0. Then I came to 1 1. And then I went to 2 2. And then there I hit a wedge. So I made some mistake in this condition, maybe. Sorry. So on to the left, we need, for the boundary check, we should not check it with m, we should check it with 0 if it is greater than or equals to 0. I'm sorry. What was I even thinking? Okay, but I'm still getting -1. And here it would be 1. Like if I have a left going cell, then I need to check that if it is 1 on the right. Okay, but I'm getting a 2 here. Let me see what I'm getting. No, I'm getting a 2 instead of 1. Why is that? Let us debug it. Okay. So I was at 0 0, and then I came to 1 1, and then I went to 2 2, and then I went to 3 1, and then I went to 42012. Okay. Okay, so actually we need to get the position of the column when we get out of this bound. So instead of putting n minus 1 here, we have to put n. I should really start reading the question. Okay, I think it is working. It is working fine. Let me check. Let me remove this, comment out this debug statements, and let's try again. I don't want to buy a premium. I'm broke. Okay, so the example test cases are passing, but I'm not sure it's work. I can't see any other mistake I made, but maybe these days I'm getting a lot of wrong answers. And what would be the time complexity of this? So this loop, I mean this function, it's a recursive function, and each function would invoke itself at most n times, a number of rows times, because we have because at each recursion we are increasing the number of rows by 1, and when the number of rows reaches n, I'm just returning it. So for each x comma y, for each in the worst case I would recurse for the number of rows times, and that I'm doing for each and every column, so that would be m into n. So it should be able to come in our bounds of n equals to 100. Yeah, so yeah, today's video wasn't very good. There were a lot of mistakes I made, so we had to debug. And apart from that, I hope to maintain consistency across this November. No miss November, I would call it. And yeah, bye. See you tomorrow.